My name is James. I go by the name of JB Hancroft in Second Life, and my presentation today is about overcoming the limitations of LSL, the scripting language, for SL and also OpenSim. My contact information is there, and it'll also be on the last slide. So the agenda is really very simple, and I hope you'll enjoy the sparseness of my slides. The agenda is very simple. There's an introduction. We have objectives. I have one objective. I'm going to cover some terminology. This is a fairly technical class, and it's not meant as a tutorial at all. So I'll go over some terminology and background, and then the main core of what we're doing will be talk about limitations in scripting and suggestions I have for how to work around that. So by way of introduction, I'm a professional scripter. I'm a game designer. I'm an award winner from the Federal Virtual World Challenge, along with Leah. I was a presenter years ago at the SL Pro conference, the Linden Lab conference, that the lab hosted, and my clients over the past 15 years have been universities, government and military, other companies doing R&D, pharma companies, and so on. So the objectives are really to provide you with some practical solutions to work around LSL and SL OpenSim limitations. We're going to talk a blend of design approach and then specific technical solutions. I don't expect to need to use the whole time. There will be time at the end for questions and answers if you'd like. So from a terminology standpoint, we understand that LSL is an event-driven language. Events, the various kinds of events, things like a message input on a listen, a link message, a web server reply, etc., are what cause the language to activate. So multiple scripts run in parallel in an object or a linked object run in parallel, often in an unpredictable order. And this turns out to be very important to achieve reliability in Second Life. Messages between scripts are called link messages. Messages between objects, we'll call them listen messages because they're inter-object messages that activate listen events. Messages coming back from a web server, a database server, we can call them HTTP messages or messages from an off-world server. Mono, as a way of terminology, is one of the two pre-compiled runtime object formats that you can choose when you're saving a script. There's a checkbox when you actually save a script, whether you're doing it in the what's called LSL 0 or Mono. Mono gives you more memory and it runs faster. The viewer, what we all know and love, or what you run locally as a fat client. And then sim or region. This is the portion of the server dedicated to simulating your virtual land objects and your experience. So one of the limitations, let me go back. One of the limitations is that there's a memory limit of 64K per monoscript. And that includes the code, the heap, and the stack. The solution to that is to run multiple parallel scripts, which my experience is that in one project I have a linked object running 50 scripts in parallel. And one of the keys to success about this is to have each one own certain data as the source of truth for that data. It owns the operations on that data. And it can act somewhat like a microservice if you think about it from an architectural standpoint. but it is the access point for the data. And as I mentioned, each script saved as mono takes up the full 64K code. So each script saved as mono takes up the full 64K code, stack, and heap space. And then there's an API call that the lab provides called set memory limit, that if you have a small script that needs to run in parallel, doesn't need the entire memory space, you can use that to trim down the footprint and improve the overall efficiency of your code. So one of the limitations is too many scripts causes lag. So I've just said you can run many scripts in parallel. The problem with that is if you run too many of them, you end up bogging things down. So one of the solutions, and this is the format that I'm going to use for the rest of the presentation here, and I'm going pretty quick, so I'm not going to take very much time, but is to turn scripts off when you don't need them. The API call for that is set script state, turning it to false. Yeah, site, I can make the copy of the slides available later, certainly. I have them in a PowerPoint format if you'd like them. But turning the things off is still taking up memory, even when it's not running. But that script will no longer participate in the frames per second activation as part of the sim. So you've done a little bit to reduce lag. As I said, many running scripts can cause lag. One of the solutions that I thought was actually kind of creative is to have an object act as a script warehouse that can send over a script to the desired destination on demand. So think of it as object A. You want to be very streamlined, and you may have a large number of small scripts that do purposeful things on demand. You don't want them running all the time, but you do want them available. And so I've used this to essentially have an executing object and a warehouse object. And you use these two APIs, the set remote script access pin sets the pin. You have to provide a pin to the second call so that you can essentially authorize the injection. You still have to have regular permissions to modify the object, but this allows you to send a script over from one object to another. It transfers the script, and then when it is injected into the second object, it will execute. It can do its work. It can talk to a manager script locally, and then it can be deleted with remove object. So this I found actually as an interesting way to implement what many would consider mobile code, not coding for a mobile device, but actual code that moves around and is sort of called in on demand. So again, we're still working with the same limitation. The limitation is too many running scripts causes lag. So solution 3 is to use off-world computing, a web server. This is particularly useful for applications that need to work with large sets of text data. For example, to store error messages text off-world in a web server. And in several examples, I've done this where I was able to go ahead and store the error message text and other dialogue text in multiple languages off-world in a web server without taking up any room within the actual LSL code. The alternative is keeping all of the alternatives to keep all the text in a script, which is poor use of memory, or a local note card, which can be slow. And I've used all three of these examples, and generally what I see happens is that people start down a path with a particular design with something that works, like let's put all the error messages in line. and then you realize you're running out of memory, so you take all the messages and you put them in a separate script, but they're still taking up script memory on your object overall. And then you move them off-world because it's easy and it's actually pretty fast. LumenLoud does keep a very high performance connection to the internet, so off-world computation is actually a decent alternative. Okay, I got ahead of myself on the speakeasy. Okay, so one of the limitations is that each script can only have one timer event, so that's pending. Okay, and this is interesting if you have a complex script that requires multiple interleaving, overlapping, stacked timers. What I've done in several cases is have a separate timers script that will manage multiple stacked or interleaved timers, which are then signaled by the recipient, the subscribing script, if you will, by using message linked. And so you can have a script A that registers the request for a timer and giving it a label with in so many seconds or minutes or hours, and the centralized timer script will manage that and take care of all the running timers. This is one of those things that it's interesting over time that you did end up developing these modular capabilities, and large projects become approachable and doable. When I first started doing LSL code, I thought that a project with 4 or 5 scripts was complex and starting to stretch things. But over time, you develop techniques and an awareness of how to do this properly. And so I've been able to do. My largest project has approximately 80 scripts running in a single object, and I'm able to manage with very low lag by being careful and using a number of the techniques that I've mentioned in here. So one of the things that happens, I'm getting caught behind them, there we go. So what happens is you start distributing your architecture out, you end up with too many link messages. So there's the limitation with that is that LSL has a queue of 64 events. We talked about events before. So in this particular case, a link message will cause an event to fire on each and every script that's running that has an event entry point for link messages. But there's an event queue of 64 events, and if you try to push more events, then the events get dropped without any kind of warning. LSL doesn't give you any way to capture the fact that you've dropped events. There's no error code or callback. One solution that I found that is actually a good debugging technique is to have a link message logging script that in the course of the messages flying around in whatever timing and sequence that they happen, the logging script gives you a chance to debug the actual sequence of messages being sent, where they're being sent from, to where, and when. And the reason this is a great debugging technique, in my experience, is it will help you confirm your design is working as expected, not only externally, in terms of the behavior, the actions that it's taking, but internally. And in some cases, I didn't realize that a particular script was sending 10 link messages when it only needed to send 1. And I didn't realize it because the extra link messages weren't causing any harm, but they were essentially noise on the traffic internally, and they didn't need to be sent. So one of the things that you can do with with having too many link messages is have scripts ignore high-frequency link messages. by filtering them out first before checking all of the other things that the script must do. So let's say if the script is responsible for servicing a particular set of, and this is a technique that I've used where the number, the integer number associated with the link message I use as an API code, if you will. So if this one is responsible for a series of numbers in, let's say, the 13,000 range, or if it's responsible for the 12,000 range, then one of the things I would put up at the very front of that, if the number is not 12,000, then return. But what this means is that I don't have, in this script, I don't have to execute a series of cascading if, then, else statements in order to know that I'm not interested in this particular link message. One of the times this ends up being very useful is in situations where there are animations involved. You have perhaps an artificially rigged entity, an avatar or a pet or something. And over the years, I've done lots of works on babies and puppies and kittens and dragons and so on. And so being able to simulate animation smoothly is a highly desirable thing. So this gives you a way to trim out CPU cycles. One of the solutions is to, you have too many link messages, and you can separate the scripts into functional groups and actually put the groups of scripts into separate prims. I agree with you, Laura. We should talk about that in terms of virtual pets and AI. Yeah, we can talk about it afterward. So one of the techniques is to go ahead and separate the scripts into functional groups and then put the groups of scripts into separate prims. Because the LL message linked API lets you direct the message to a particular destination prim, then only the scripts that are in that prim will execute, will trigger an event, a link event coming in into that prim, reducing the amount of messages that all of your scripts need to consider. So this is one of those things that you might want to consider as the evolution of a project, where initially all of the scripts might be in the root prim, and all of the scripts are processing every event in parallel. But over time, there are trade-offs. If you're in a performance envelope where you really, really need this technique, then I think it's useful to separate out some of your scripts into an isolated prim and do this. Okay, see you, Bixel. You might consider this link message routing by being able to go ahead and designate a particular prim to send the messages to. This is for linked messages, not for listens. Okay. So for scripts that broadcast status or data updates, where I've done this approach where a particular script owns a particular set of data, and then it can make the data available on a request and response basis to other scripts that are running in parallel. But for scripts that need to broadcast status or data updates, one technique that saves a lot of link messages and therefore a lot of downstream performance is actually to have the cache the previous version of what was sent out. So if the data hasn't changed, don't send it out. And this ends up being part of the kind of the existential contract, if you will, between the scripts, is that this script owns this piece of data. As the data changes, it will send out a broadcast message in a sort of a publish and subscribe, a pub sub type architecture. But if the data hasn't changed, don't send it out. My suggestion is to have a way to force the message to be sent out, and the easiest way to do that is just to invalidate the cache of the previous one. So now that we've talked about distributing things out, again, if you have too many link messages, one of the solutions is to localize code. I've done this in the case of it's a localized code where you need to reduce link message noise. So if it's local, if it's a procedure call, it's not a link message. You're not invoking any kind of unnecessary noise. And I guess one of the things that I would recommend is that you should avoid over-factoring your code into too many scripts. Now, this can be difficult in very large projects. What this means is that I would suggest you think about organizing your code in a sort of hierarchy that is associated with the call tree or the flow, or really the think of it as a linked graph relative to performance rather than organization, rather than organizing all the scripts associated with foo in a particular object, or all the procedures associated with all the procedures associated with foo into a particular script, and having them logically organized in what might make sense for my brain. Go ahead and organize them so that the ones who call each other a lot are local to each other. That's what I mean when I say localized code. So this next one is very interesting. It's one of the ones that plagues me, causes me to lose sleep in Second Life. In Second Life, and to some extent in OpenSim, although their behaviors are different in this regard, you have to take extreme measures to control the order in which scripts reset, start, or run. There are very, very complicated sets of parallel scripts, and of course, by their nature, it's exhibit widely varying or intermittent behavior. Thank you, Puppy, for photobombing my lecture. I know, good talk. So the solution is to make your design as really as asynchronous as possible, ideally allowing the restart of any one script at a time, with all the required data being provisioned by other scripts. This is something that I would highly recommend that you do from a programmer productivity standpoint. What this does is it decouples your design build test sequence from having to do a complete restart of everything on each and every code change. So what this means is you can go into one particular script, make a change, save it, recompile it, and any dependencies that script has on other scripts are provisioned at runtime by the very nature of your architecture. And so you don't have to reset and restart and begin your sequence of whatever it is in a very laborious way. So if you're doing QA and testing, I would recommend you consider that. So SL, this next one is that SL has region restarts and rollbacks, and I highly, highly recommend. This is a hard one to get your head around, but I highly, highly recommend that you think about restarts and rollbacks during the design phase of your project before you get deeply invested in an approach that might be crippled by a rollback. So my experience is that you can detect a rollback by keeping some state in an off-world or external server and watching for SL essentially to turn the time clock back. It's very, very difficult. It's not impossible, but it's very difficult to get SL itself to realize that it has had a region restart. Restarts you can do. Rollbacks are the hard one. There is a changed event that will fire for a region restart, but there is nothing for a rollback. You have to detect that on your own. Yes, the internet never forgets, but SL do. That's correct. SL can be good at forgetting things. So you can detect a rollback by keeping some state in an offload server, like perhaps a last used Unix timestamp, something like that. And if time starts going backwards, then you know you have a problem. Okay, get a little caught up on the speakeasy. Okay, so I have been blasting through this, particularly because I think I'm used to things being a little more extemporaneous rather than following a script, but I've really, really tried to behave myself with the speakeasy. So the conclusions I have are think about the structure of your design before you start coding. This is a bad habit that I have, that I will often jump into coding and then just do a project and start coding before I really started to think about the design and the architecture, and designing with performance in mind is something that comes with time. It ends up being a learned thing. Think about small modules as, refactoring code or factoring code, but not too small. Think very, very carefully about how your scripts run in parallel. And look in that regard for the unexamined assumption. Things where you think it's working okay, it's working just fine when it's running by itself, but because of some interaction with the external world or behavior that's unexpected with using a Linden Lab API, perhaps, that the scripts, when they're running in parallel, don't operate the same. Think about performance ahead of time in terms of where the control loops are going to be, where the events are going to be. And back to that part about having the runtime provisioning of dependencies make your design easy to maintain and to debug. So I have flown through my lecture, and I think I'm at the thank you part. So thank you for your time and attention.